Okay, so again, we want to set up our ratio test first. We want to figure out our radius of convergence, and then we want to test the endpoints to find the interval of convergence. So the limit as n approaches infinity, okay, our ratio test is going to look like this. So x minus 2 to the n plus 1, okay, over n plus 1 to the power n plus 1. In the denominator, we're going to end up with x minus 2 to the n over n to the n, and we want to know where this ratio test is going to be less than 1. Okay, so we want to rearrange this, limit as n approaches infinity. So we're going to end up the x minus 2 to the n in the denominator, x minus 2 to the n plus 1. That's just going to be left with x minus 2. Okay, for the series part of this, we're going to end up with n to the n in the numerator over n plus 1 to the power n plus 1 in the denominator. Okay, so, and we want to know where that's less than 1. Okay, so how do we simplify this, the series part of the sequence part of this expression? So the x minus 2, I'm just going to leave alone. That's our power series part. This part here is going to simplify this way. So we're just going to write this as n to the n over n plus 1 to the power n. Okay, this essentially is just one fraction to the power n. And that fraction is going to, as the limit as n goes to infinity, that's just going to be a ratio of 1. So we're just going to end up with 1 to the power n. And we have this extra factor, plus 1 here, so we have extra factor of n plus 1. So we're going to split it up like that, and then we're going to evaluate our limit. So this part here, and again, maybe I'll just write one more step in here so you can see what I'm doing. So limit as n approaches infinity of x minus 2. This portion here just becomes n over n plus 1 to the power n. So this is going to become 1 to the power n, which is 1. And then we have this part here, n plus 1, and we're going to let the limit as n go to infinity. So this becomes, when I work this out, this becomes x minus 2. This portion will become 1 to the power infinity, and this is going to be 1 divided by infinity, which is times 0. Okay, and then so we end up less than 1. Well, essentially this is going to be all equal to 0. So all this, we have the center of convergence at x equals 2. Okay, so that's going to give us our center. And the radius in this case becomes infinite because any value of x will be able to satisfy this inequality. So we know that x is centered at x equals 2, and the radius, our radius is infinite. As xer will satisfy the inequality. Okay, it's because we're multiplying by 0. Anything times 0 is going to be less than 1. So any value of x works. So the interval of convergence then becomes infinite. The interval of convergence that doesn't look like convergence. Convergence is going to be from negative infinity to positive infinity. Okay, so there we go.